Hey folks, this is a short presentation about the RFC I've written last week, and it cares about the server-side rendering aspects of our Vue applications. And the idea of the RFC is to actually combine the best of both worlds, like making Vue a first-class citizen in Ruby on Rails and make it really easy to plug in a Vue application into Rails and simply turn on server-side rendering. And I'm going to explain a bit why and how and what are the complexities and caveats. So let's get started. I just want to say one word about server-side rendering. So we usually understand, how usually client-side applications work is we load JavaScript from the server, the JavaScript gets parsed and compiled locally, and then we manipulate the DOM in order to create a beautiful JavaScript application. And this is pretty much the most standard way of doing it, but it has a few, not issues, but it increases the time time to content for the application, because we need to contact the server delivers HTML, the HTML contains information about the JavaScript file to be loaded, then we need to make another request to the server, we fetch the JavaScript file, and then we have to parse it, and then we have to render it. So the idea of server-side rendering is to cut a few of those parts out and deliver a meaningful rendering to the user immediately with the first response. So we deliver with the initial HTML response that we get from the server, we immediately deliver the application rendered as it is going to look like after the JavaScript code has been executed. So this is the whole idea about server-side rendering, to get to give the user access to the application more quickly. And this is the primary reason why we want to do this. The second reason, this is very GitLab specific, I also want to make sure that Vue apps are better integrated into the Rails ecosystem, because it can be a bit cumbersome to figure out where to mount a certain application, and I think there's not a uniform mental model yet how to do this. Okay, so I explained a bit why we want server-side rendering, but there's also a really important additional information here. HTML can be rendered in a streaming fashion. So all the browsers that we use today, and this is actually true for the last 20 years, are capable of streaming-based rendering. So the second the first byte arrives on the client from the HTML file, it will start parsing that HTML file and immediately start to render that HTML file to the screen. So a streaming parser is capable of showing something before it actually knows about the end of the document. And this is an additional advantage of server-side rendering, because we're going to deliver HTML to the user and not a JavaScript file, which needs to be loaded completely and then parsed and compiled. And only after that it can render something. So from first principles, there is no theoretically faster way to serve an application than to serve it with the initial HTML file. Streaming-based rendering is the key part here. So let's talk a bit about our current front-end architecture. We do have one or more Vue applications on a lot of our pages. They get mounted at runtime and therefore rendered after the initial page load. We do have an API, GraphQL or REST API in our case, that we access from our Vue applications, and we might use one or more state libraries like Redux or all the fancy Vue ones that exist out there. And my RFC kind of accounts for that, because server-side rendering can be done in a very different way than I propose here. You could just set up a Node.js server that kind of acts as a reverse proxy in front of the Rails application, and then you have to pass through all the requests through this Node.js proxy, and only for those requests that are concerned about rendering a Vue application, we would do the rendering on the Node.js server, and everything else would still be delivered and proxied through this Node.js instance from the Rails monolith that we have. This adds a ton of complexity, and it also makes the thing slower, because there's an additional round trip in the network, etc., etc. I particularly don't want to do that. I don't want to set up a complete set of infrastructure, a complete set of pods just dedicated to reverse proxy our existing applications. Besides the added complexity, it's cost, and it's tricky to do that properly. So here's the proposal. I want to make Vue apps a first-class citizen in the Ruby on Rails monolith. It should feel natural to build and add a Vue application into the Ruby on Rails monolith with the added benefit of getting server-side rendering for free. And this is the way I think about it. So this is a highly artificial GitLab page. It does not exist, but it kind of like illustrates the idea. We want to have two applications on one page. We have the editor application, we have the sidebar application. And on the first page, we expect that we immediately see the editor and the sidebar rendered. And after hydration, and I will talk about this a bit later, we're going to have like full interactive access, like we have full interactivity with those two applications. And this should all happen without the user noticing. So we get the niceties of a Vue application, like we can build incredibly complex and nice looking applications. And at the same time, we get the performance and speed of like HTML directly delivered to the user. The whole idea is that we do not have a single Vue application that needs to be rendered. We have parts of our pages are Vue applications, and they can be individually rendered into the specific frame. I'm using frame here because in the Rails community, since Hotwire, Turbo, and Stimulus became a thing, decomposition of the application into frames is kind of like the hot topic. The fun part for me is we are already doing that. We already mark specific areas of our Vue and of our page as a frame. We don't call it frames, but it's exactly the same idea. Like here we have some reserved space for a Vue application, and here is another Vue application, or the whole page is a Vue application. It doesn't really matter. It's just we need to be able to render it. So why we want to do this? The goals here are quite clear. Significantly reduce time to content. That's the primary goal of server-side rendering. Render Vue apps with or without state directly in Ruby, and doing so by using a lightweight sidecar process instead of a Node.js server. And in order to have like a migration process over time, this requires explicit opt-in of an application, of a Vue application. So if you build a new Vue application, you can do it as you do it today, or you can explicitly opt in into server-side rendering. Or if you want to decide to migrate an existing application, you can also do that. And there should be no perceived regression for the front-end developer experience. That's kind of important. We don't want to make things more complex as they already are. Okay, how do we implement that? My proposal consists of a Ruby gem that includes a native extension that is written in Rust. It would utilize the Rust V8 bindings that are maintained by the Deno project, and it would be started and fully controlled by the Ruby process at runtime. So when we start the server process or the application will start the application render runtime, and then it's all about managing resources, timeouts, controlling those resources, etc. But it could be done strictly from Ruby. What we utilize here is V8 isolates. This is pretty much the thing that happens when you open your Chromium browser and you create a new tab. A new tab is its own sandbox, its own scope, its own container. You can do whatever you want there, and it will not interfere with anything that happens in another container. The other thing that we need to do and want to do is we want to ensure that we don't have cold start problems. So we want to pre-compile and pre-run the Vue apps. We want to ensure that we have like the lowest possible memory footprint, that we use the least computer resources possible. And we want to tightly integrate that with Ruby on Rails by providing helpers and a specific render target in Rails that kind of like feels like if you would render an ERB or an HAML file today, and the rendering happens throughout the regular request response cycle. So it's really easy to reason about. And we also would make sure that server-side rendering never gets into the way of the server application by making sure that the actual runtime that renders never runs out of memory, like a fully controlled process. And we would evict the stale isolates, the rendering instances, by monitoring them closely. This is pretty much how Cloudflare controls their workers. Why a Ruby gem and not a dedicated process? I spoke a bit about like Node.js before, but I think a Ruby gem with a native extension better fits what we actually do here. We have a monolith. We want to have full control within the monolith. We don't want the added complexity of deployments outside of this monolith. It's already complex enough. And I also think it's not necessary. It's a much more simple concept. And we actually have full control over all these resources. And it also has an additional advantage I did not talk about before. There is no need for serialization if you have to pass data from the Ruby world to the JavaScript world, because it's the same. It's like the processes are co-located. We're just sending a bit of, we're just sharing a bit of memory on the same server. I think this proposal results in an overall simplified architecture. No added security concerns. No authentication uses. Proxying complete Rails pages that do not even have a Vue.js application. So this is in particular in comparison to using a Node.js server as a server-side rendering instance. Okay, how we are going to do this? This is a demo gem that has set up the Rust V8 bindings. It can already serve JavaScript compiled and rendered JavaScript back to Ruby, and you can start the compilation process from Ruby. Please take a look. It does nothing else. Like, there's a lot of work to do in order to make this, really work properly, but it's doable and it's not super complex. It took me a few minutes to create this demo gem. Okay, how it is actually done. We would load a bundled JavaScript application. So this is key here, but we already have the system for that. We use Webpack to create bundles, and we can just create a bundle for the server-side rendering instance as well. And then EasyOverrun would just take that source code, the JavaScript source code, and parse it, compile it, and run it, and then return the result back to Ruby. So in these two lines, plus the file reading line, is everything we need at the lower level to make this work from the Ruby side. And this is not everything. We obviously also need to better integrate in Rails. So I would like to see this is working is we have a render target for applications. So we have this nice little turbo app, which does not exist today in Rails, but this is the borrowed, it's borrowed from the turbo frame hotwire stimulus thing. I just pass an ID of an application and declare it as a turbo app to be rendered, and it will automatically compile, render the JavaScript Vue application, and inject it into the HTML that is output and sent to the user in the initial request. Like, that is all you should, that should be all you need in order to make your application work. And this is how the control flow looks like, or the actual render flow looks like. So we have our two applications, editor and sidebar. We also have a navigation. We also have probably, something at the bottom that is not a Vue application at all. But as our Vue application is just another render target in Rails, it almost behaves like another partial, right? Like, we render the navbar, the user avatar, but then we also render the editor app and the sidebar app. And at the end of the day, we just get a nice, simple HTML file that we can serve to the user. And this is how it looks like in Ruby on Rails on the server side. We could just introduce the turbo app format here, and then if there's a request that wants us to return a turbo app, we could also do that from the server. So it gives us the capability of dynamically injecting applications even. And I think just the concept here is very Rails-like, but it has literally no effect on the Vue Vue application development. But it makes it very accessible to developers that are familiar with the Rails world. Okay, we have a few issues, obviously, with server-side rendering. It's not a particular concern of this RFC, but when I presented this yesterday in the front-end group, I think there was a lot of questions that were targeting like the issues around server-side rendering. And I think some of them can be answered, but some of them definitely need to be explored further. So when we render an application for the first page load, it cannot do anything, right? Like it does not really work because the JavaScript parts have not been initialized. This is a known issue, and it has pretty much been solved by every big framework that we carry, or library that we are using today. Like if you want to do it in React or in Vue or in Svelte or in Angular or whatever, they all, Svelte is a bad example, but they all have the concept of rehydrating the client. So this means after we have served the HTML, we still need to initialize our JavaScript code to give back the interaction, to make the application interactive again. And this is part of every library, and it can be done. The problems really happen when you look at the automation of this. So when we rendered the Turbo app, we kind of also expect that the rehydration happens manually. So the way I reason about this is, if we have this nice little Turbo app render target for the sidebar, it automatically renders, and this is what you see here with the div, and a very complex Vue app, obviously. And then we also have the JavaScript code that is going to take this render Vue application and will rehydrate the JavaScript code with that existing HTML on the client side after it is loaded. The idea is that the time to content is going down, and that the time for compiling and initializing and rehydrating that application is so short that before the user starts to use it, it's already done. We also have state on the server side, and there was an interesting question yesterday. And I think my answer was it's probably an architecture problem, but I also believe it needs to be considered when it needs to be supported. And the way, like both React and Vue support Apollo React and Apollo Vue both support both libraries support this in a very similar way. Every query that is executed during the server-side rendering process is stored into a state variable, and during rehydration or hydration on the client side, that state is taken and used to render the application as it is. So there is no flickering between what is the HTML representation and what we actually see. I also think this issue isn't completely solved, because obviously querying during the server-side rendering process takes some time. It can delay the rendering on the server, and it might increase the overall load time if there are too many queries, which is not really a desirable goal. But what I have seen in the past working really, really well is opting out certain areas from rendering. So if there's a really complex query that we know that take like 5 seconds, we really don't want that to have server-side rendered, but instead we want it to be excluded and executed after the client has rehydrated. And this is also true for parts of the application that just don't need to be server-side rendered. Let's say we have a really complex interactive application. It might be totally okay to just render the application frame to give the user like a good first time to content, but then only, we have this nice little loading skeletons, but only initialize the highly interactive component on the client side afterwards. Okay, here's the RFC. I would really like to see server-side rendering at GitLab. I think it's a necessity, and we are honestly quite behind when it comes to that part of the stack. I really would like to see more comments. Please also add critique to the RFC. I think it's not perfect. There is a lot of improvements that we could make in the future. Like we could also have streaming-based rendering on the server side, which would be even cooler than just buffering the complete output into the HTML. And thanks for listening.